Oh, okay. Start with a bang, huh? Okay, so I think almost everyone is connected, it looks like. Cool. So thanks for coming, everyone, especially early on a Wednesday morning. This talk is web programming from the beginning. So before we get started on the history and technology of the internet, I want to talk a little bit about why we're here and what we're hoping to accomplish with this workshop. First of all, I should make it very clear that we are not trying to. We're not teaching you this stuff because we think it's a great idea for you to like write your own low-level TCP implementations. Usually, there are going to be libraries that are going to be a lot better for you to use. Rather, the goal is to give you a framework that will help you understand the lower levels of the libraries and frameworks that you do use. The web it's a monster legacy system. If any of you have worked on code that's even like 4 years old, you probably know how quickly cruft can accumulate. The web has been around, the internet has been around for over 40 years, and it's very difficult to understand in one giant byte. But if you can see sort of step by step how it evolved and what questions people were trying to answer at each stage when they developed these technologies, it can make it a lot easier to understand the decisions that were made and to make sense of the system as a whole. Excuse me. So the workshop is coming in 6 sections, each of which is trying to answer a question that people were struggling with in the past, and we're going to be covering this in roughly chronological order. The first section is asking, how do you get information from one computer to another? This is something that was not obvious when people were first doing it. Old computers were monoliths. They were designed to work on the data that they had, and they weren't designed to talk to each other. The second question is, how do you find when you've got more computers networked together? How do you find the one that you want to talk to? This became a problem as more and more computers got connected. Third is, how do you find information that you didn't know you needed? So up to this point, there was sort of there was the assumption that you knew what computer you wanted to connect to, and it was just a matter of finding it. But as more and more people came online, it became an issue. People didn't even necessarily know where to find the information that they needed. And then finally, we'll look at the modern web after that. So each section is going to have a historical piece and some exercises. Obviously, we can't. We don't have 60s technology to work with, so we can't. The exercises are going to be a little more abstract at the beginning. They won't be directly related to the technology that we're talking about in the historical section. But as we go on, Tom, could you get the table of contents up there?
Yeah, sorry.
Thank you. Yeah. Okay. So sorry, these are the 6 sections. As we go on to the later sections, you'll see that the exercises sort of come together and start relating more closely to the topics we're discussing. So a few words about the exercises. You've probably already seen that you've got sticky notes in front of you. Please use the green ones when you're done the exercise, and please put up a red one if you're having trouble with it. That will let us and the helpers know when you need assistance. Please don't be shy. If you're confused about something, odds are that someone else is too.
If I can interrupt. With that, unfortunately, we may not be able to go for 100%, but it's better if we can assess. If you think, oh, I must be the only one behind, it may be that everyone is behind. That already happened once today. Everyone was unable to do a thing. So it's great for us to have the feedback that, all right, lots of people are stuck.
Yeah.
And then it may be that if a couple people's things aren't working, we might have to circle back or email afterwards to figure out what's going on.
Sure. Okay. Anything you wanted to add, Tom?
To what are we doing here anyway?
Yeah.
No, I think we're
Okay. Okay, cool. So we're gonna move on to some basic exercises, which I'll let Tom describe.
Let's see. Okay, so first off, so I've seen many people have been able to open a terminal. Has everybody also opened, so the second instruction on that front page was open that web programming. Has everybody got that open? It should be a GitHub page. There are 4 links in that to different exercise guides. And I'd like you to open all of those now and keep them in separate tabs so that if we don't have internet later, it'll be fine. Which is the thing that might happen because we might end up switching to our local network so that we can talk to each other better. So can everybody open a terminal and type Python 3 actually in it? And our first goal is going to be relatively simple. We're going to try to square the number 3294, which happens to be the number of PyCon attendees last year. And I guess if you squared it, maybe that would be like the number of connections that could happen between people in theory or something. So can everybody, and I'm going to demonstrate here. I'm pulling up a terminal. Bump it up a bit. I'm typing Python, but I'm not going to type just Python. I'm actually going to type Python 3, but for some people it might be Python. Hopefully, though, whatever you type, you end up with Python 3. Once people have done that, okay, and go ahead and square that number, which was, we'd have to refer back to our exercise guide 1 here to find out what number it was we're supposed to be squaring. And it looks like that number is 3294. So once everybody take sticky notes down, put up a green sticky note once you've opened a Python REPL and squared this 3294 number. And then some of these exercises, if you're real stuck, eventually I will, or someone will start typing something out. So 3294. Maybe I don't know how to do times, so I'll just multiply it again. Cool. So green sticky note up if you've got this done. Red if you're having trouble with it or you want a hand. And I guess there are just 3 of us, or maybe 4 people that might be helping out with this kind of thing. We'd like everyone to have one of these terminals. That's a good question. Totally. What happens if you just type Python?
So if you do have it, please do put up a green sticky note so we know that you're all right.
We look pretty green. Great.
Yeah, we've got 1 or 2 people who came in late. Do we have more?
Oh, sure.
More of the sticky notes?
Yeah. Ahmed, do you have the sticky notes? We've got a couple of new people, so if you can grab them. Sorry, I didn't.
If you came in late, please raise your hand, and Ahmed will give you some sticky notes.
This is Ahmed. He's great.
Yes.
Oh, okay. Well, you can do it anyway.
He doesn't have any.
This is Rose. She's great. I'm Tom. I'm also great. We forgot to introduce. All right, so we're looking good on squaring this number. Now we're going to type more lines of code. There are more ways to mess up. Okay. This is outlined again in these exercise notes. So if you wanted to look at trying to get this later. We are going to connect to another computer now. So similar to the telnet session you have going on still in another terminal, hopefully. So ideally you have both of these terminals. Netcat, thank you. Netcat. Now we're going to do the same thing with Python. So we're going to need 4 lines of code here. They're written on your exercise. I'm going to type them now. They are import socket, s equals socket.socket, s.connect. It says IP address. Let's keep using thomasballinger.com because apparently I had the wrong IP address for that. hopefully that will return. And then as our last line, we can send a message. I'm going to send, "Hi, I am Tom," carefully avoiding the quote. And then hopefully in another terminal, you've got your great. Great. Got other things coming in. So go ahead and take down your green sticky note and put it back up once you've been able to type these lines. It sounds like it'd be easy, but there are a lot of characters that we type. There are a lot of ways to get these wrong. So totally fine if you don't have that yet. Either because you need more time, or because you'd like a hand in spotting a typo, or because you have network setup issues, which we're going to encounter lots of.
This isn't actually a workshop at all. We're actually showing you our new startup. It's going to beat Slack. Are you able?
Going on. What does it say next? Oh, next it says, what were we even doing? So we just typed some code. Now I'm going to try to take questions to like a good question, for example, would be, what just happened? What were we doing? How am I seeing words on my screen? Does anyone have a question like that? I'm saying explicitly this would be a great time to ask questions. There should be all sorts of things that are new and confusing. I have some questions I could use as backup, but do you have any questions now? Yeah. Will we be considering any security issues during this is a great question, and we will mostly be saying, here's a thing that's not a great idea and we shouldn't do in general, but we're doing here. But that's a great question. What kinds of security issues have we dealt with so far? So far, we have this netcat thing, and if it's safe, then I guess we're safe, but we're also writing Python code, and that's scary. Let's do a scary thing now, actually. Let's write one more line of code where we say, s.recv, and then a number like that. This is going to bring down some bytes from the network. And this is where it starts getting scary, right? So I'm going to receive these bytes. They party out. People are typing all sorts of stuff, right? I want to say this is pretty safe, because all I did was get some bytes. But all sorts of scary things can happen when we do this. Hopefully, so what Python did here was it built a string object and put that in memory. Hopefully there's nothing wrong with that. There is in a lot of systems where you get a buffer from the network and then something happens to it. It's like, oh, it was a little bit too big and now it's some code and someone else ends up executing it later. It's all sorts of things like that. Here, this should be pretty safe. We might be offended by something we see in here, and I'd ask everyone to follow the code of conduct, right? But mostly what we're asking is, display these bytes for me. And the bytes might not format well. It might mess up our terminal formatting. It might turn our terminal blue. It might make a beep, because there's a terminal character that makes a beep. So there are a lot of things that could happen. Because we're printing the string, the Python wrapper of the string, most of those things won't happen. We'll just see like what the string would have been. But right, we have to be really careful with that, because as soon as we take this code and put it on a birthday card, now we're exposing ourselves, right? Or if we take this code or these bytes and try to run them, that would be a problem, absolutely. So we'll talk a little bit more about that. All right, another question like that. That was a great question. Doesn't even have to be that good.
How would you have done this, say, would you have been able to do what we just did, say, in the 80s or the 70s?
Oh, that's a good question.
So
that's a good point. We'd be stuck
definitely
with
not-
some less exciting language.
Definitely not in Python. TCP, I think, came into common use in the early 70s. So yeah, you would have been able to do it, but you would have been writing in C.
Yeah. That's a great question. Yeah, this is a TCP connection, and that's because the default argument in Python, I'll have to open a fancier thing here. If we import the socket, actually, let's just look at socket.socket. If you look at the arguments here, it's saying like there are four default arguments we actually passed. And the AF inet says, hey, this is an internet connection. Like, this is not a socket for communicating between processes. This is a socket for talking to the internet and then for networking. And sock stream means TCP. It means like, okay, I want a stream of bytes. So sockets can do other kinds of things, but the default case is a common one, which is the default. So yes, this is a TCP connection, which we'll talk about in a little bit. Yeah. Anything else? All sorts of questions. Okay, I'll bring out some of mine.
And don't worry if you're not following all of this. Again, the idea here is to get some basic code that we're going to be building on later. We will be talking more about what IP and TCP and some of these words mean later on.
And even if we don't, I think a goal of this workshop is to give you some hooks to put knowledge on later. We'll give you some knowledge for those hooks now, but hopefully by typing code and being excited about putting bytes on other people's computers, there's a place for that knowledge now. And then you can go read, we'll suggest books at the end, but at least you're playing with this. All right, what is going on here? Nobody has quite asked that. There's a fundamental question, like how did the bytes get there? And maybe that's because we're so used to this. But right, your computer made some radio waves, and then there's a router somewhere, another computer that's tinier, and it said, oh, I guess I'll send these somewhere else, very roughly. Right? So again, this is not a lot of knowledge, but just to answer that question. What is a socket object? I think is an interesting question here, which is, and I think a good thing to do with that question is to not fully answer it, or answer it in the way of like, what is a file? Like, we don't really know what files are or how they work, or maybe some of us do. We know about inodes and the way file systems work, but most of the time we don't need to know how files work to use them. We can still open a file read bytes from the file, put things in the file, open a new file. And I think that is a very reasonable mental model for the socket stuff we're doing now. It's like I created a thing. It wasn't a file. It was a different kind of thing. But I just asked the operating system. This is a conversation with the operating system in the same way that creating a file object and then calling methods on it is a conversation with the operating system where you're saying, hey, operating system, I'd love it if that one file we were talking about earlier, if we could put these bytes in it. And we don't really need to know from the Python side how that works, although it's very interesting. I think that's something that works. I'm just going to go ahead and move this guy. Was there anything else I was real excited about? We got the hacked one, which is great.
Yes.
We are not on a special Wi-Fi network. Has anyone, we'll talk about it a little more later, seen that B that we used when we were sending things? Is everybody, who's in Python 3 here? Using Python 3 today? OK, cool. So you had to presumably put a B or call an encode method in order to send. And I saw a lot of text, so we've successfully been sending some text. That's a thing. Maybe we'll talk about it later. But that's a thing we have to do because we're sending bytes instead of strings, and there's a difference between those things. Call good?
Yeah, I think that'll do for now. So now you've kind of monkey typed this, and you've got a basic idea of how to open a socket, even if you're not entirely clear on what that means. Don't worry, it'll come. So to make this a little more interesting and get you actually thinking about how to use these things, we're going to get you to write a basic chat client. So that means you can start with that code that you actually used to connect, copy that into a file. Those 4 lines that are they still up there?
Oh, sorry.
Yeah. So try copying those into a file, and then see if you can make a Python program that runs at the command line, right, and lets you type text in, and then sends it off over the socket, and then gives you back another prompt again. Okay, and again, take off your take off your sticky notes if you've got one, and feel free to use a red sticky note if you need a hand.
Yes, in this to do with internet replace with my IP, that's a task that I meant to do, and we're going to use thomasballinger.com there for now. The same thing we've been using.
Yeah.
We didn't want to let you know that you could put a string there. We wanted to make you think you had to use numbers, so it would be a revelation later, but that wasn't working.
Right, and you had them open the exercises as well, so they should.
Yes. Does everyone have this sheet on their computer for easy copy and pasting? I can help with that.
Yeah. Is that good? Whoops. Where is that?
If you're stuck,
my
I can give
goodness.
hints too, if that's helpful.
Tom, where do you have that? Where do you have the exercise sheet here?
It's in the browser there.
Yeah, which tab?
Oh, good question.
There it is. Okay. Okay. Is anyone having trouble knowing where to start?
If you have a question, other people have the same question, so I can
Guaranteed.
ask around. I'll put this on the board as well. Yeah. Sure. There are some hints down here about functions to use, but I'll leave it up there. For anyone that's feeling pretty stuck, I'm going to start to write pieces up here, but also I'd like to answer questions anyone has. Ooh, okay, thank you. That's what I should actually be monitoring for this. Great. Okay.
How many people are having trouble connecting to the internet?
The internet
I
generally,
see, yeah,
like web stuff.
yeah, like connecting at all. Yeah, there's a few people.
Okay, so it's probably not you, right? Let's now blame it on like too many people using the internet. If you could share a handout with your friend. Or
The other thing we do is get them working on locally. Right.
work on
Like,
locally.
like if we just or we could.
If you need more terminals, you can. If anyone's done, at the bottom there's some extensions of other fun things that you could do with this, making it a little better.
Oops. That's not working. Stupid. Okay. Okay. How do I exit out of this? There's no control.
Control-C.
Then where's control?
I got it. I did control.
Oh, it's on
Yes,
caps lock.
yeah.
Okay, great.
I do need it. I
Okay.
should start doing.
Okay.
There's a lot of people stuck though, so I would like to start doing
But
the.
how many of them are stuck because they're not on the internet?
That's a good question. I
Yeah.
don't know.
That's what I'm worried about.
I don't think it's as many as are just stuck because they don't.
Right.
Okay, I'm going to just type
Okay.
a
Okay.
basic one
Yeah,
for
yeah,
folks
go
to
for it.
see. All right, for anybody pretty confused, pretty lost, we just assumed a lot of things. We're like, hey, based on seeing this, you'll instantly be able to write a program. Now I'm going to start to write one and kind of narrate what I'm doing. If you can, like, ignore me if you're making good progress on yours, but we're going to start to write one here. So I remember I had to. I remember I had to import socket, so I'm going to start with that. Then I'm going to instantiate it again. Oh. Oh. Next, I'm going to say connect. This is a funny line. I'm going to say while true, meaning forever. Keep doing this loop and forever until I Control-C out of it. The thing I want to do is, let's print what I get back. Print s.receive. And let's also,
This doesn't have all your key bindings, so.
yeah, I'm not sure what's, am I on the server? No. And then, this is the wrong chat client. Oh, I am on the server. That's why it doesn't have my event bindings. Okay, here's a fancier one. That's real fancy.
You're missing an E on true there.
Thanks. And let's put more lines, a bit more clear. maybe it's working. Who knows? So here's an example of the kind of the raw pieces. We can't see here, but it says 1, 2, 3, 4, like before, after that part. What else? So I can answer any questions about this. There are a lot of issues with this kind of server and how this is not the real way you might write one, but it's a nice way to just start playing with sockets with this. And then at the bottom of the exercise, there's some extensions you might want to do. Any So someone just asked, why are we using UTF-8 encoding? What is that about? Or did you mean why UTF-8 in particular, or like what is encoding all about? Or sure, yeah. So in Python 3, we have two kinds of strings. We have ones that are just a series of bytes, which are good if you're reading from a binary file or if you're getting bytes from a network. And we have normal text, Unicode strings. We just call them strings. And that's the thing that we get from input. And because I'm getting a message here from input, that's going to be a string. The type of it is str. So I need to turn it into bytes. And there's a mapping, and you can go from bytes to Unicode strings if you decide how am I going to translate between those two. And there are a lot of different ways to do it. And if you only know one, it should be UTF-8 because it's useful in a lot of cases. We are not really doing this topic justice, so I have some handouts that do a little more. That'd be great, because I'm not doing a very good job answering your question. So, and we're punting on that by using this handout.
Are you constantly sending empty strings, or is there?
Great. Am I constantly sending empty strings? So you're thinking that the program must run while true, and then we run this code real quick, and then we run this code, and then we run this code, and often that'll be an empty string. Is that what you're saying?
Or I don't know what input is, but it's
Got it. Yeah. So input means sit at the prompt and wait for the user to type something. So there will be something in there. It might be an empty string, right, if they just hit return right away. And right now we are just sending those empty strings. Yeah. And what happens when you send an empty string? That's a great question. I have no idea. I assume it just doesn't send it, but I don't know what's going on there. But it's not going to happen a ton because the user would have to type enter, right? Because this is a blocking call. Input just sits there and waits for user to type something. So this code isn't running that fast. It's not a real tight loop. It's saying, get here, wait. And the other nice thing is that this receive call is also blocking. If there's nothing to receive, it's just going to sit there and wait. So a frustrating thing is maybe you won't be able to type much here, which could get me into the issue with this.
I'm wondering if we should move on to the next section.
Sure.
Okay. How many people actually have it working? And if
That's a
they're
good
not even
question.
connected?
How many people? Oh, sorry. Could you put a green sticky up if you've got? If you've got a working, for some definition, whatever definition you want of working, but you have some code and it's running, and maybe you have a socket, maybe it's talking to something. It's a fair number. We're a little weak on this side. Is everybody? Could you actually put, just to make it clear, could you put a red sticky up if you don't? We still might move on. We're probably going to move on anyway, but trying to get a sense if you feel like you're not yet satisfied, things are not working for you for some reason. I'm going to call that good for now, I think.
How many people are still not connected to the internet?
Oh yeah, who's still can't connect to the internet at all, like the web? One hand? So it looks like we're better for that. Just one person can't connect to the web, can't get websites? Okay, cool. That's good.
Okay. Okay. So I think we're going to move on to the next part of the exercise. If you weren't able to get a working implementation, there should be a sample implementation in the exercises document that Tom sent out.
Is that true? There should be. I don't know if there is, but there ought to be. Or you can copy this. Yeah.
Yeah. So just take a minute. If you don't have a working implementation, go ahead and copy this, and then we're going to go ahead and try and alter that a little bit.
Just going to check to see if they do.
Okay.
Oh, it looks like they don't. Sorry.
Okay.
Okay, so we're going to lose people
Okay.
for a bit. Sorry about that.
Yeah. Let's not put this. Hopefully it's not too much to copy.
Sorry, where are you? This you?
I was on the.
Yeah, it's supposed to be. Just a note about that handout. You don't need to read that now. That's just to make us feel less bad about not doing this topic justice. You can get away without reading that at any point. You ought to read it tomorrow or tonight.
Okay. Can you go ahead and put up a green sticky if you have successfully copied that down, or have your own working chat client that's able to connect to the server and send a message? Okay, and a red sticky
No
if you're having
greens.
trouble with it.
Everybody, yeah?
Okay. Oh.
We get sound, yeah.
So someone just brought up a really excellent question. He was asking what this 100 is in the receive. That is not a port. It's a byte count. So it's basically telling the operating system, this is how much information I'm expecting to get in. Please give me that. And this is one of the things that you would not want to do in a live program. You'd want much more clever logic around that, because if you get a lot more, or if you get a lot more data than you're expecting, then your server could crash or worse.
For anybody that made it to the more advanced parts, you're kind of dealing with some of the issues of like, well, if this just sits and waits until you get some bytes. Sometimes this returns immediately, even if there's a small number of bytes. Like there are a lot of issues here that you can look at that handout later to go further with.
Yeah, for sure.
Should we?
Does that answer your question? Yeah, cool.
Yeah. So someone else asked about the B. Why are, when we're printing these things, is it a B? Because it's this weird byte string type that is a different kind of, Python has two kinds of strings. A byte string is the kind of string you get off the network, and it's just a series of bytes. This is the thing I'm saying we're not doing justice, it's on that handout a little bit. But Python 3 is very good at keeping these two very distinct, which is nice, because otherwise you end up with all kinds of encoding errors, like when you go to a web page and the apostrophes all don't work. That's the kind of thing we're fighting against here. Yeah. Should we Sally?
Okay, I'm not seeing a lot of green post-its. How many people have managed to copy this down and have it running properly? Can I see some green or see some red?
I think we're,
Either way is fine, honest. Just want to know.
let's call it, I think.
Yeah, okay, this looks pretty good. So the next exercise, and I think we'll have a short break after this. The next exercise is going to be modifying this a bit. We're going to be, after the break, we're going to be talking about designing protocols. And so before we do that, we're going to warm up a bit by designing a bit of a protocol of our own. So now I realize this is going to be a challenging question because this is a pretty awesome chat client that we've got so far. But does anyone have any ideas at all for how maybe it could possibly be better?
It's not
Maybe.
Slack yet.
It's not Slack yet. Let's see. Names? Sorry? Memes? Oh, yes, definitely. I like it. Image macros, yeah. What else? Decoding Unicode characters as they come in, yeah. What else? Usernames? Yeah.
Usernames, that's a good one.
that's a
What
good
if we
one.
knew who was
Yeah.
maybe the level of discourse would elevate if it wasn't anonymous?
I don't know, it seems pretty
Interesting.
good so far. I mean, better than the average Reddit thread. Any other, you looked like you were going to say something?
Trying to figure out how much to receive and making sure you don't take too much.
Yes, yeah, getting more clever logic around the buffer there. I mean, fortunately, this chat server has a pretty high quality population, so I'm pretty sure no one's going to try and crash it, right? Fingers crossed. Any other ideas? Wow, we're actually pretty close to
I
Slack.
guess
apparently.
so. Let's
Great.
get our pitch deck.
Okay. So let's try. I think usernames will be a good sort of start. How could we change our clients? We don't have access to the server. All right. So assuming the server is not keeping track of anything, how could we use our clients to implement basic usernames here? Does anyone have any ideas for that? Sure. Sure. So the suggestion there is to prepend the message with your name. What about any refinements anyone might add to that? Sure. Yeah, ask the user what their name is before connecting to the server. Yeah. And maybe we'll also want some sort of distinction between the username and the message. Maybe we'll try putting like a colon or a dash or something after the username. Yeah, I think, yeah. Then, a timestamp. Sure. Right, like when, sure, yeah. So the suggestion is putting a timestamp after the username as well. Oh, the IP address. Right, yeah, because you could have 3 Bobs. So one way to ensure that you're talking about a distinct user would be to include the IP address. Right. So the question there is whether we're going to ask the user for their username or get it from an environment variable or something. I think probably asking is easiest. So I think there's definitely more that we could do here, but I think this is a pretty good place to go if we want to try and have a break in the next 15 or 20 minutes. Let's start with sending. The basic version of this will be just send the username followed by a colon. And you can hard code the username if you want to, but if you want something a little more interesting, try prompting the user for a username and try to send the IP address and a timestamp as well. Okay, but we'll call that an optional part of this particular standard. Then, oh, love it. A carriage return at the end of the line. Yes.
Let's just say a new line for now, for folks
Yes.
not familiar with carriage
Yeah,
return. But
sure.
that would be neat, because then you could tell the difference between the end of a message and the next person's name.
Yeah.
That'd be pretty cool.
That would be great. Okay.
That's an idea. There's
So-
something to that.
So start with a username, a colon, the message, and then a new line. Okay, and again, I'll ask you to strip the stickies off your computer and then put up a green one when you're done and a red one if you would like some help from our lovely assistants.
I bet you can do even better, though. I bet you can. Even more.
What, you're done already? Nice. Oh, no.
That's my version.
Can we
But we
can we
can
get
do
the
better.
server up on the screen too,
Oh,
so we
yeah.
can see all these fancy new messages?
Uh-oh. No, we can't. Let's see. Okay.
We're
This
gonna
is-
need you
that's
all
nice.
to sign over the intellectual property rights to this this protocol. We're gonna need it. Yeah, that's
Yeah.
right. That's right. No one leaves this room without signing one. Okay. Oh, I'm seeing a lot of usernames here.
So now that we have usernames, like you could start to do some fancy stuff when you receive the message too, right? Like if you knew it was always going to be a colon in there, then maybe you could get your message and split it on a colon and say, oh, this first part must be the name, and I can do whatever display stuff I want with the name. Maybe I could just display some users. I could block people or something. Variety.
Yeah. But of course, doing something like that depends on every client following the protocol that we've defined,
yeah,
right?
what
If
if
one
somebody
person is
doesn't?
leaving off a colon,
Yeah.
if some people are sending timestamps and some people aren't, you have to deal with that
It'd be
possibility.
great if we could agree on a set of rules about what text to send.
If it doesn't match the syntax, send them a message saying it doesn't match the syntax.
Right.
That's it. There you go. Sorry? Oh, sure. Go back to the code.
Yep.
Or maybe you can be showing both.
Is this it? Yeah. No, that's not it. This is it. Real simple. Did I miss a paren? What's that about? Valid syntax. No, it's a B. There we go.
Okay, so it's almost 10.
Yeah, we're gonna revise a bit.
Sure. Yeah. Okay, so I think we're going to spend 5 more minutes on this, and then we're going to have a 10-minute break. Does anyone need a hand with anything?
Oh yeah, yeah. Let's disperse. Yeah.
Yeah.
This. Okay, I think if you're feeling good about this, let's go ahead and break for 10 minutes. Let's plan to come back at 10:12, I guess, for a full 11-minute break. There might be coffee outside, maybe? Is that a thing?
Five, everyone. So we're going to take a break and meet back here at 10:15. Stretch your legs.
Extended. We just extended it by
Yes.
4 minutes.
Yes. Yeah. Oh, sorry. Oh, you did. Oh, I'm sorry. I didn't hear.
But 10:15 is better. 10:15
Yeah,
is actually
10:15 is
Most
good.
people didn't even stand up. Now
Okay. I think we're going to try and get started again. It looks like almost everyone's back. As promised, we're going to start getting into the historical section. I'm going to tell you a little about how we get information from one machine to another, and then Tom's going to talk some more about TCP/IP. So hopefully, some of the stuff that we have been doing will be a little more clear to you after that, and then we'll get to some more exercises. Okay, so. I'm not an expert graphic designer, as you might be able to tell here. So that's why I'm using photographs. This is exactly what computers looked like in the mid-'60s. So try and take yourself back to that era. Okay, it's the early mid-'60s. It's 1962, say. You've got a slick beehive hairdo and a mini skirt. This is generally good advice. You should always imagine yourself like that. And computers are the size of a room. Only large corporations, universities, government agencies have access to these things. And you want to, so you're accustomed to thinking of this as sort of a specialized device that is running one program at a time and on data that it has locally, right? But people are starting to think about the problem of how to make the same data accessible to multiple programs, which at the time meant multiple machines. There was a lot of innovation going on in the '60s. Around how to best share data. You see a lot of work on basic database theory. I think the Codd's paper on relational algebra didn't come out until the early '70s, but people were, that was sort of based on earlier work that people had been doing and experimenting with how to format their data in a standardized way that could be used for more than one purpose. People were also starting to work on operating systems, which might seem like a pretty basic thing now. But again, up to that point, computers would, you'd load up one program and it would run, and then you'd load up the next program and it would run. So there was this idea in the air of having the machine have a program that was always running that could allocate resources to, like, whether it's mostly processor time at that point, I think, but also memory, right, and any input or output. So as they were thinking about this, it was natural for them to start thinking about how to connect computers to each other. And it's more complicated than it seems, right? Because each computer has a different instruction set. It might have different ways of storing the data. So how do you sort of translate between them? And this brings us to a sort of recurring theme that we see in the history of networking, which is the idea of encoding. Here's one example of encoding that you use all the time, even if you are not super familiar with it. And this is how you this is an old ASCII chart, and it basically shows how you can interpret a string of ones and zeros as letters, right? So if you let me come over here. Right, so if you look, I think these are the first bytes are over here on the left, right? 0, 1, 0, 0, and then you can read down the last 3 bytes, 1, 0, 0. You would interpret that string as a D. And incidentally, that's what we're doing when we put a B in front of a string in Python. We're telling it, take this string of bytes and think of it as letters using this encoding scheme. There's nothing magical about this. There were other competing standards, though this one won out. So
Right.
we just did that.
Slightly behind.
Where
We're
those,
close, though.
Where are those
A
other
little
slides?
further.
Okay. Okay.
Maybe not.
Okay. So we're going to talk a little about encoding at an even lower level than that, though. The answer to this question, like it's common to think of computers as really storing ones and zeros, but really what they're storing is physics, right? You've got magnetic patterns, or you've got changes in voltage, or various electronic differences that we then sort of interpret as ones and zeros so that we can think of it on that higher level. So the short answer of how you get data from one machine to another is
Wires.
yes. Yeah, is that people had to come up with protocols like we were talking about before, right? You need to agree that on both sides you're going to interpret these things the same way. So they would send varying voltage along the wires, and that's still and that would be interpreted as a string of ones and zeros on either side into whatever way the receiving machine was storing that. So and then this is sort of a recurring theme in networking, because once you've got those ones and zeros, then you can add more conventions on top of that about how you interpret them, right? So ASCII is one example. Binary encoding for numbers is another one, right? Like when you say that a string 100 really represents the number 4, that's what you're doing. Is you're assigning meaning to something that could be interpreted any number of different ways. So, yeah, I'll hand it over to you to.
Yeah, we were going
Talk
to look
about
at.
sockets.
Do Wireshark first.
Sure. No, we're going to do Wireshark after you talk about.
Okay.
After you talk about.
Now we just
packets.
spoiled it. Wireshark's coming. Wireshark is very exciting. Very exciting. Right. So continuing up that stack, right? We have how we're physics to like, oh, we'll call this a bit. These two different voltages, and then going up to bytes, and then maybe those bytes have meaning. Is this just encoding or? Okay, no, onto okay, yeah. So now we're moving on to this next one. Like, how do I kind of both find the machine that I want us to connect to, and how does my information find it? So now we have this, and again, this is like because I don't know the history as well. This is a false version of history, but leads us somewhere useful, which is we have these different computers, and we want them to talk to each other, and maybe at first you just have a wire that goes from one computer to the other, and you just know that like, oh, I turn on this circuit over here, and that connects to this computer. Maybe you have a bigger network. Maybe you start to have to kind of address things. Maybe you even have an addressing system where all the computers at Harvard, all 3 of them have, or all 10 of them have different ways of kind of talking to each other. And there's like a system, and they have numbers or something. But then once you want that network there to talk to some computers at another school, maybe it starts to get a little more complicated. Even if each one has its own number, you don't have a single wire that goes from each of the computers. Each computer at Harvard doesn't have a wire to each one at Stanford, and there's not even it starts to get hierarchical kind of, so maybe there's a central one. Maybe you can have a school that has 6 computers, and they all send a message to one central computer, and that computer knows where to send it, but maybe this gets more complicated. And we had a model for this, which is kind of the phone system. The way that like early phone systems, if you manage a operator that listens to the call and it's like, oh, you want to talk to Cincinnati? Great, I'll put you through to Cincinnati. You're trying to talk to Dr. Smith in Cincinnati. I don't know who that is. I don't know that number, but based on you telling me that they're in Cincinnati, I'm going to take your call, hook it up, send it off to Cincinnati. Then there's another operator there that says, oh, you're trying to talk to that person. Great, I'll route you through. Maybe there are more hops because you don't have every city in your board, and so you kind of it's an international call, it has more hops. So there's this hierarchical kind of like each operator deciding where this message will go that is really analogous to the IP system, to this system of like, sure, say that everyone did have a unique number they're going to use for their computer. And we've been using thomasballinger.com, which is jumping ahead a bit. But say we started and that number had worked. We just have the number, but we have to find that computer. Every time we send out a piece of information, it's going to be marked with, I'm going to this computer. And then each intermediate little computer on the way there, called a router usually, is going to route those packets, or let's talk about packets, this little piece of information on to where it thinks would be a good place for it to go next. So this is this IP routing system is about. You just have a bunch of routers doing this packet switching that is great. I just got some radio waves as we do it now, or I got some radio waves through a wire like they used to do it, and now I have to decide where to send it, and maybe I can tell that this is an IP address on my network, so I'm going to send that message over to you. So if we were, and we can't do this demo unfortunately because the PyCon Wi-Fi network is kind of blocking some signals. So if a demo we wanted to do was that one of you is going to start up a server, and we're about to write servers, and then your partner is going to connect to that server. But that information doesn't flow directly between your computers. It goes through the router. And on the PyCon network, they've made a sensible decision of saying, you know what, some kinds of traffic, we're just not going to allow those. Like we're going to do some threat analysis. Like when people are talking to each other on random ports, like that's usually not good. Let's cut that out. I don't know exactly how the decision was made, but for some reason on this network, we can't do this. We brought a router to try to do this ourselves, but we can't get internet on it, and we think it'd be too much to kind of switch over and back. But if you'd like, maybe if you stick around the end or talk to us another time, if someone can make a temporary Wi-Fi network, then that'll give out its own IP addresses, and your computers will actually be able to talk more directly to each other. But for now, it's going to be have to through a server somewhere else. What was I so excited about before that? So IP is how we're routing this around. Then I kept using the word packet. I tried not to, but I kept using it. That's this idea of a piece of information. Maybe when I send my email or I send my chat server message, maybe it's too big, and someone along the way says, you know what, I'm going to send this in 2 separate pieces. And maybe only one of those gets there, because one of those gets directed to like, oh, that seems like a good place for me to send this information is to this other router over here, and it will forward that one, and then the second half gets dropped. Someone is like, well, I was too busy. My CPU wasn't fast enough to get around to sending off all those packets, or I didn't have the bandwidth. I just didn't send that one. So an issue we have with these systems is those packets getting dropped. You hear about dropped packets. So even over this idea of like, oh, I can send with IP, I can take some bytes and send them to somebody, that's kind of not enough to reliably get some bytes to somebody. And it's not enough to get those bytes in order to somebody, because your message might get split up, and one takes longer because it takes a different path. So even though maybe the speed of light's kind of constant, like these routing algorithms might not be. So we have these kinds of issues, and the sockets we've been using have been TCP sockets, and TCP solves these issues. Somehow, we have some handouts up here that we'll give you at the end about how it does that. It's very cool. But TCP is this protocol that solves this for us and lets us say, you know what, either this is going to get there, or I'm going to let you know that we dropped the connection. You're no longer connected because I was unable to get this information over there. If you send something, either it's going to go through, or we're going to totally give up and you're not allowed to send more things, and it's a big event. Versus, I'm going to send you some stuff, send you some stuff, send you some stuff. You just get some of it, and you might not be able to notice. So IP is a protocol. This is the thing we were doing before when we were trying to design, figure out some rules by which we could all connect to the chat server and have a better experience. That we were trying to design a protocol. That was a higher level protocol up to the text level on top of TCP, which is itself on top of IP, kind of. So this is that layering as it goes higher, and I'm doing some of the higher levels.
Okay.
Wireshark yet, or do we do?
Sure.
Okay, cool. All right, so I mentioned those things. I mentioned the TCP, the outstanding connection that we hold is this idea of, all right, I'm going to connect to that server, and there's actually some information exchanged back and forth. So when you say connect, stuff happens, and that might fail, meaning it wasn't able to connect to that other machine, or it might succeed, meaning it actually was. Information was exchanged back and forth. And then every once in a while, it's going to check in again, and then at some point, if the information is not able to get through because you're not online anymore, or a packet gets dropped, and we're not able to retransmit it, then the connection has died. And I mostly know this because I've read about it some, but a great way to discover this is this program called Wireshark, which I'll let.
What
let you go
interface do
through.
I want to be on? Here?
I do. Oh, this is even a different interface.
Yeah.
Wi-Fi looks good.
Okay.
Very bottom one.
Okay.
Yeah. All right.
that.
Sounds good. Sure.
Okay.
So this is this thing, and what we're going to see here are,
It still won't
I
let me
guess,
start
packets
capturing.
would be a good way to describe it.
It's not letting me start capturing. Here.
Oh. So maybe this is the wrong one.
Yeah, that's what I'm wondering. Okay.
Here, can we-
Then, oh, Okay.
What was that?
Oh, okay. It is already listening. Never mind. Okay. So let's get a new. That's not what I intended to do.
Should
Sorry,
I
this
open
is.
up
I'm
chat server?
on
I'll do a
Tom's
chat
computer
server.
here.
Right,
Yeah.
the plan is to connect to the chat client, right?
Yeah.
Okay.
Yeah. But we want to have it visible while
Oh, right,
while
right.
Wireshark is running.
Okay. Here's this, and great. You said it
Okay.
is working.
Yes.
I don't.
Yeah. I think it is capturing now. Okay. Oh, except it must not be because it's
It must not be
showing
because
it.
I'd have crazy traffic.
Okay.
We'll talk about
Okay,
Wireshark
well,
briefly.
we might
while I
have to
press buttons.
skip this.
Okay. Oh, it's so exciting. You're really missing out. So this is a great program that you can download. It's this free open source program. And what it does is it lets you watch all the traffic on your computer. And there's probably more traffic than you expect because, say you're, there's no Dropbox icon. Say that you had an icon on the top right that was Dropbox, and it's like, well, that's just running in the background. It's not doing much. And then you look at the traffic here and like, oh no, it's talking all the time. So you have lots of programs on your machine that might be talking to a server. So it's kind of nice for that. It's kind of nice for exploring protocols. It's nice for debugging your own network things. Do you have anything to say that I could play with it?
I don't. Yeah. No, I wanted to show it.
Yeah. Here, let's go on to. We can just bring it back later.
Sure.
Um,
What do you?
does that work?
Okay. Yeah. I guess we can just move on to the server.
Oh, we're going to do server next. Okay, we can
Yeah.
play with it while we're doing a server.
Okay.
Okay, cool. Great. So the next thing, this exercise and the previous one were split somewhat arbitrarily in that this is no higher level than the previous one. We kind of needed this information to understand how either of those exercises is working. Now we're going to do the server side of sockets. So this is the idea that someone else or you is going to connect to your machine, and it's kind of a two-way, asymmetric thing at first, like to create that connection. Some of you did netcat space -L to start a server if you couldn't connect to our server. This is that process. I want to walk through the exercise now.
Sure.
Let's bring up the. So this is going to say connecting to your neighbor's computer, which we're not going to do because of the packet thing, or the network thing. But you can do this on your own computer. So we want you to open two terminals. Demo here. Mine are going to look like this. Yours are probably in actual separate windows. And in one of these, you're going to say netcat. I'm going to do it on the left. In one of these, we're going to say netcat -L. And you get to choose a port. It can be anything you want. I'm going to do 1, 2, 3. Well, I'll do 4,000, so it's a different one than we did last time. Mm-hmm. And then I'm going to connect to that server. So I've just basically started a server. It's going to listen for one connection there. I say localhost. Oh, we didn't do DNS. So there's this other thing that let us do Thomas Ballinger in the first place. I said we were going to just do an IP address. ThomasBallinger.com is not an IP address. Localhost is not an IP address. There is another layer of translation that's happening. Somehow, you get to say google.com, and it just figures out that that's whatever it is, whatever google.com is. Or Thomas Ballinger, and that just works. Great. So Rose just connected. On this side, localhost is this really special one that corresponds to a really special IP address that is not a normal IP address. It means, you know what, don't actually just talk to my computer. I'm talking about myself. So for all of us, it's like a pronoun. It means myself, no matter who you are. So we're all going to connect to localhost, but we'll all have 50 different localhosts, and because that's our own machine that we're connecting to. So you should have, if you get to this point, let's do stickies. If you're at this point, you have two terminals. One of them has netcat-L with a number. The other one has this. And if you type here, it shows up over there. If you type here, it shows up over there. This would work on two machines as well, except for this network thing. So this is a fun thing to do at home with your friends. Just send each other bytes.
What's your Tmux prefix?
Q.
Just Q?
Command Q.
Command Q.
Or sorry, Control. Sorry.
Okay. Perfect.
Control Q. All right, stickies.
Gonna wanna
Who's
zoom
this working for? I need a green sticky if it's working, if you're good. Oh, a lot of green stickies. And red if we're stuck somehow, or confused, or if you have a question, you're welcome to just ask. Yeah, I was. I wanted to explain that. Well, I was going to say it was kind of magic. So for some reason, this corresponds to that. There's this thing called DNS, domain
name service.
name service. Thanks, domain name service. And it is in charge of doing these translations for us. They're not that important, right? They're not that fundamental. We could use the internet with numbers, but it's sure nice not to have to. And I'm not going to, again, this is another one outlined well in a handout.
Well, DNS was actually pretty exciting for people when the internet first started, because before, if a machine moved or if information moved onto a different machine, so like, say some guy has an account on a computer and you want to get files from him, and he moved to a different university or something, then you would have to find that out offline and find out what his new IP address was.
Okay, so
Whereas
that
if he
does sound
has
pretty
like a name, if he has a name associated with him, that can move with him.
Okay, that
Yeah.
sounds great. That
Yeah.
sounds really useful. So somehow we're looking this up. It's a separate process from sending the messaging packets. When you type it, your operating system goes out and says, hey, does anyone know who this is? Or it remembers from the last time. Or it goes out and talks to some routers and says, hey, does anyone know who this is? And then maybe they know, maybe they don't, and they have to go look it up. So it's this querying, like shoutcast style, like, does anybody know what this is about? And then it comes back. So not really, I guess, to answer your question. Okay, so now we're going to do servers. So are people good with this? Because now we're going to do this with Python. And it's about twice as hard as the first one, about twice as many lines of code, and like 1.5 times as many things to explain. So I'm going to do this in the Python interpreter. That's how I'd recommend you do it, although when you make typos, it's kind of hard. But then afterwards, when we do the project, you're going to write that in a script. I wasn't clear about that last time. OK. I'm going to cheat. I'm in trouble. So once again, we're going to import a socket. Once again, we're going to, so this is in the exercise, right?
It should be.
OK, this is also in here if you'd like to see it closer. Hopefully you have that. I'm going to make a socket. Instead of connecting to something, I'm going to bind this socket. I'm going to say bind. And this is like an IP address and a port. The first argument's a little funny because this is my own computer, right? But I have multiple network interfaces, like if you had multiple Wi-Fi cards, and you always have the localhost one. And at this point in the exercise, we're going to start encouraging you to listen only on localhost, because we're about to start doing some things where security is an issue, where if someone else did know your IP address and was able to connect, you're going to write some not great programs that they might be able to exploit. So we're going to start just using localhost here, so only programs on your machine could connect to this. Right now, it says 127.0.0.1. That's the magic number that means localhost, but it's easier to just type localhost. Localhost. Next, we're going to say how many. It doesn't matter that much.
Do you have anything else bound to 1, 2, 3, 4?
Hopefully not. That's a good question. Next, I'm going to do this listen command. This is saying how many connections is my operating system allowed to queue up? Because remember, these connections can happen, and they have to be responded to before my application even gets to them. They have this connection thing where the person connecting says, hey, I want to connect. Normally, if I hadn't said I'm listening now, my operating system could just drop those radio waves, right? It's getting things from the router that says, hey, someone wants to talk to you on port 42. And before this, or in this case, port 1234, before I ran this code, the operating system would say, great, I don't care. We're ignoring those packets. Now we're going to start listening to them. We're going to accept incoming connections on this port. The next thing I'm going to do is accept a connection, because I've done all the things. Yeah. This should be a blocking operation. This is going to just sit there until someone connects to my machine. So I'm going to go ahead and connect over here. We can use Netcat for this, or we can use Python. By now, we might be pretty familiar with the Python. So if you want, you can do your old, import. Whoop. import, but typing is hard, so I'm going to use netcat. Netcat localhost.
You can try hooking up your chat client to it if you want.
Sure, yeah. Connect, great. And now this accept call finally returned. And we're looking at the meat of a server of any kind, maybe a web server or a chat client server or something. What we just returned here is a tuple of two things. I wish I had this object so I could kind of manipulate it and extract the different parts of it. So I'm going to use this Python
that
REPL
again.
trick. Oh, yeah, sorry. I'm going to say stuff equals underscore. Underscore is a magic thing in the Python interpreter that says if you just had something and you forgot to do something with it, if you just evaluated an expression and you didn't save the value of it, I'll save it for you in underscore. And so now we've got stuff here. And now let's look at the two elements of stuff, maybe. We can,
Okay.
I can tell
Separately?
it's two things. Yeah, for either one, 0 or 1. 0. Cool. So this is a socket, a new socket. So now in this program, we're talking about two different sockets. We have the server socket, which works sort of differently. We call accept on it. We never send or receive with it, but it's the same kind of object. And then we have this client socket. It's not stored in a variable yet. I guess it's in the first element of this stuff tuple. That represents our connection to the person that connected over here. So a lot of times in a server, what you'll see is this kind of boilerplate. And then over and over, we're going to accept connections and then do something with that connection. This second element of this tuple that accept returns is the IP address and port of the connecting socket. So we didn't write the code for this, but it looks like, well, it's actually assigned. But it's doing something where we know about what it's doing in Python. It's creating a socket and connecting. It's not actually written in Python, but the C API is really similar to the Python API. So that's interesting information, but we're going to throw it away. We really care about this first element here.
You want to name it something?
That's right. I can just play with it. So we're going to have to do a few things. I'm going to take that first element. First element. I'm going to call it S. I shouldn't do that because then I'll lose my reference to the
You
old
want a
one.
0 there.
Thank
nothing.
you.
Yeah.
So I guess I'll call it client S. And now this is just a two-way communication socket, just like we had when we were doing client stuff. Client socket dot send hi. New line maybe. Whoops. This is an error we should all see a lot today, probably. All right. If I'm going to just write an arbitrary string, I could be putting fancy characters in it, right? I could have this stuff in there. And it doesn't know how to send that. Those are not part of that ASCII set that we looked at before. So if I'm going to do that, I need to encode those. 8. Or I just need to send simple bytes. B, hello. Cool. It shows up over here. And we can do receive just like before. So a server is only special in that it has this little socket factory, which is that server socket. And it keeps spitting those out. And then each time we get a connection, we can do something with it. If you were an HTTP server, you might listen for someone to connect and then spit out a web page back. If you are a chat server here, maybe you just, well, we're going to ignore the chat server case because you need a lot of people to connect, and they'd all have to talk to each other, which gets into some of the things in the advanced portion of that first exercise. So definitely look at that if you're interested. Concurrency comes into this. But we are going to do a simple server where you're going to let someone connect. They're going to say something, and you'll say something back. They can say something again. You can say something back again. Maybe a transformation of the text. Maybe you could count how many characters are in it. Maybe you could, they ask for a joke, and you tell them a joke. Maybe it's they give you some math, and you do that math for them. But the goal here is to write a server that does something. Yeah, we just scroll down a bit. So we've got, and the nice thing about these exercises, because you've got these handouts, if you don't finish them now or you want to look at them later, you can absolutely do that. These are pieces of code you might want. I'd recommend opening this in a browser tab. I will, after 5 minutes or so, start writing, maybe actually quicker. it would be nice to wrestle with this, but is a lot of stuff that you're not familiar with yet. If you refer to the example we just typed out, or that's a little bit higher up, you can start to do stuff with that. But for more guidance, in a couple minutes, I'll start writing a similar server. So the goal is to write a server that lets people connect. You can use Netcat or you can use Python to connect. And it should do something. A common one is an echo server, where you take that stuff that they said to you and you just say it right back. Maybe you could say it back twice. That'd be pretty clever. Or maybe you could say it back capitalized. Or yeah, I would transform that stuff and give it back somehow. So it's probably not fair to call this a chat server because that implies more users. This is a server where anyone can connect and you send something back. Okay, so we've got a couple of minutes where we're just going to try some things, and then in a couple of minutes I'll start to write something up here for anybody that's stuck. Ready? Go. Take down your green sticky notes now, unless you're already done, just for some signaling. That's fine. We haven't we haven't given you a lot yet. I would start by taking the code that was up above and pasting it into a text editor, and then trying to run that code and see if you can get that to work. Ideally, you want to run that code and then connect with Netcat, and you should see things happening. Oh boy, and I'm really excited to show you Wireshark as soon as we're at a good stopping point, but we have to write this first. Oh, that's so exciting. But not yet, not yet. Yeah. Questions that are sort of general, that are not about, specifically, well, I'm happy to help you with that too, but there's a lot of stuff we don't know about how this works yet. I just wrote that number 10, and I guess I said something about it, but if you don't remember, that's fine. I can repeat. Okay, listen.
Yeah, so for one person I was with them, and I told them I had them open the Python docs.
Yeah,
I
nice.
showed them how the arguments read.
Great, great. Okay, that's a good, yeah, that's awesome, yeah. Not really.
Cat localhost connection refused.
Uh-oh.
Did not connect to the internet.
No, but local.
No, localhost, yeah, yeah.
So like, I think it's a Windows firewall thing, but
For who? Is it multiple people or just? Okay, keep working on our spoilers here. Dot. Message. Oh. Has anybody gotten this error here yet? Address already in use? No way. Okay, there's a magic incantation we can use to get rid of that. It's in the handout, I think. Here it is. Pretty cool. All right, any questions? Happy to can answer a question for the whole group or individually. Can we see green stickers if you are at a place you like with this? You don't have to do red ones yet. It's totally reasonable to not be finished, but. People are just trying to read this. So I'm going to bump it up. Well, a lot of people are just trying to read this, so I'll make it bigger. Great. There's the other magic thing for that. Yeah. I'm so proud of line 10 up here that I want to explain it to everybody. So I remembered that s.accept returns a tuple of two things. And in Python, we can do this version of assignment called tuple unpacking, where I say, you know what, I know that there's going to be two things. And instead of getting them as one object as a tuple, I want both of those elements. And I stored the first one to new connection, and I stored the second one to underscore, which is not a special variable, but there's a convention of like, that's probably not very important if I put an underscore there. So this is my way of extracting that first one in one line. It's the same as if I'd said this square 0 equals new connection. Not much better than that. Oh, cool. Yeah. This is, I mean, If you're done, you could think about other things you could do with this conversation, maybe a more interesting transformation. Something that might actually be useful is a math server where you send in math and it does it for you, or a spelling corrector server, or a capitalization server, or who knows. And everything's a web service these days, right? So something that you don't want to do yourself, you're too lazy to do. Oh, Ahmed, would you? Someone waved? No. Okay, is everyone's sticky notes accurate? Can I have greens if you're feeling okay about what you've got? Red if you're feeling kind of stuck? Oh, sorry. An extension for this one is that you could accept multiple connections and then have them talk to each other, but you run into concurrency stuff. And if you refer to the first exercise handout, they'll have some stuff with that. But we'll just give this a couple more minutes. Yeah. Oh, dear. So Python 2 lets you be really lazy with that. Yeah, thank you. So did everyone notice that? The demo on the board was broken, and if you got a encoding error, great, good job, you correctly copied this. I've now added a B right here. think we're going to move on because we're so excited about this Wireshark demo. So this is going to let us see and maybe start to understand some of the things, or at least find out that more stuff exists. This is super exciting. Oh, there's already that Dropbox thing coming up. I can let you. Yeah.
Sure. Okay, so Wireshark, and we were hoping to show this to you earlier. Wireshark is basically a program that sits on your computer and listens to all of the stuff that's going on the sockets on your machine. So you can use it to spy on what your computer is doing. I'm going to start it up right now. Hopefully it's working now. Yes, I'm going to continue. Okay, and now we get to see every line here on top. Can people see that all right? Is it big enough? Yeah. So every line that's scrolling in here is some sort of network activity on Tom's computer. You can see he's kind of a busy guy. So it's kind of scary, actually, what our computers do when we're not looking. Fortunately, thankfully, we can filter this. Okay, we won't get into the syntax of this too much, but basically we can ask it for specific types. Oh, do you know
One,
what
two, three,
port
four,
were
I
you
think.
listening on? 1, 2, 3, 4.
I'm not
Okay.
listening. It's just sending. Yeah.
Sure. Okay. So now we're only, so this line is, again, don't worry about the syntax, but it's basically just telling Wireshark that we're really only interested in packets that are coming to or from port 1, 2, 3, 4. So now if we make something actually happen there.
Let's just do both at the same time.
Whoop, sure. Do you have the server listening already?
The server's listening.
Okay. Oh, I see. You're just recessing it. Yeah, I can do that. Okay. Okay. So now we're gonna connect to the server, right? And then we start seeing these packets coming in. So this is basically the first 3 packets here are the sort of standard TCP handshake, and you can see. So you can see it starts with the client sending a SYN packet. If you look at where my arrow is right there, that basically means, hey, I'd like to connect to this mailbox. Is anyone listening to it? The server sends back a SYN ACK saying, yes, I am listening to it. ACK stands for acknowledge, and then the client says, all right, cool, we're connected. I still want to talk to you.
And notice we haven't sent any we haven't done anything in this program yet.
Yeah,
so
we
it's
haven't
just
actually
making the
done
connection.
anything here. Okay. Oh, and also you might notice that the bottom window is showing more details about each packet. So if you look at the very bottom window down here, this is showing basically the actual bits that are being sent on the wire in hex rather than bit by bit. And then on the right, it tries to translate the bits into characters if it does, if it's possible to do so. Not every byte corresponds to an ASCII character, but some of them do. So you can see after the initial handshake here, after the initial handshake, the first thing that comes back is a message from the server saying, please input your name, right? If we look over on this window, that's what's happening there, right? And then if I send something, so my name is, oh dear. Okay, and the terminal's a bit messed up. That's all
It could
right.
have sent new lines, but it didn't.
Your Excellency, because that's how I like my computer to talk to me. All right, then we get some more packets coming back. Where is Your Excellency? There I am. There I am. Oh, I've got a space between the E and the X because that's just how excellent I am. All right. Yeah, so Wireshark it's a pretty big hammer. It's a tool that can do a lot of things, and frankly, I don't know a lot of what it can do. But it's really a great way to see what your programs are doing when you're playing with this stuff. Right. Just remember to look up the filter that you want, because if you're not filtering, you will get.
It's kind of fun too. Yeah.
You will get everything that's going on your computer.
So there are nice command line tools to do kind of all the particular things that this is doing, and even to do exactly what this is doing, more or less. But if I'm just exploring, I really like this graphical tool for learning more about networking very generally.
Yeah, for sure. Okay, and I think we're probably up to the next break. When we get back, we're gonna. Sorry, did you have anything you wanted to do first?
I was like, we could push for it, but yeah, I guess we can. Yeah, that's fair.
Yeah,
All right.
I think
One
we
more
better.
break.
Okay, so it'll be another 10-minute break. We'll gather back here at 11:25, when we will be talking about the web.
Yeah. We'll finally get to the title. What this is about. Web programming.
Okay, we're going to get started again. This next section is, we're down to section number 4. I don't know that we're going to get all the way down to number 6, unfortunately. But we'll get as far as we can. So the next question that was facing people after the internet was working, and there were actually quite a few people on the internet for 10 or 20 years before the web was created and became a thing. A lot of what people were using was email existed before the web. There were bulletin board systems. There was a lot of FTP. A big part of the use of the early internet was getting chunks of data from another computer. Again, there were a lot of university users, and by this point, we're talking about like the late 80s, early 90s now. By that point, there were also a lot of personal users connecting. But the problem they were facing at that point was that there were so many hosts on the internet that it really wasn't feasible anymore to just know what computer was going to have the information that you needed. So that sort of model of just connecting directly to the computer that you want to connect to no longer really applied, or at least it wasn't ideal in all cases. So people had been thinking for a while about how to deal with that, and there were a few competing solutions. One of them, there was something called Archie that would basically it basically crawled the internet and sort of aggregated all of the file servers that it found. So you could connect to a local Archie server and search through all the files that were available, and then it would tell you where to go get them. There were more sophisticated experiments along those lines. One thing that actually looked like it came out around the same time as the web in 1990 or 91 was called Gopher. It was pretty amazing. If you Google it, you can maybe find some example sessions. But the model was very similar to the internet, but also different in interesting ways. The idea was that someone who had a computer with information on it could create an index of the information that they had using hypertext. So rather than connecting to the computer and searching through the file system, you would connect with a Gopher client to the Gopher server, and the server would have an index of different directories or resources that you could access. And what was really revolutionary about this was that some of the resources you could access were not actually on that computer. They could have links to files on other computers or to other Gopher indexes on other people's computers. So this is where you start seeing the idea of linking your information, linking to other information that someone who's viewing this information might be interested in. Before that, resources were very, at best you had sort of a bibliography model where you look up a web page and maybe it would tell you about, or not a web page, sorry, a file, and maybe it would tell you about other information that you might be interested in, but then you'd still have to use other means to get that information. Gopher and the early web brought together these ideas and said, no, if I'm already looking at this resource, I want to be able to go to the related resources right away. That should be one process. So the web did eventually beat out Gopher. Why is actually kind of an interesting question that I think we won't get into for time reasons. But let's talk a little bit about how the web works. So we're basically remember that networking sort of builds protocols on top of protocols. So at this point, TCP and IP were already well established for things like email. So that was sort of solid technology that people could work with. So they started building these other protocols. HTTP was a protocol that got built on top of that stack. So it assumes that you've got a TCP socket to a computer, and it sort of specifies how you can get the hypertext information that you're looking for from that computer. So let's go to a demo over here. Whoop. Put your password there.
Yeah.
Okay, so to start with, and you guys can type along with this if you want, it shouldn't be too long. Let's try netcutting google.com and see what it, oh.
Port two.
Sorry?
Port.
Yeah. Okay, hopefully that's gonna clear
Did
internet
it?
connection is.
It worked.
Oh, okay. Okay, so now we've created a TCP connection, which we've done before. Google, the server that's listening on port 80 on this machine that we found, is not sure what we want to do. We happen to know, just by convention, a lot of web servers tend to run on port 80. So we are going to see what we can get by typing in an HTTP request. Whoop, there we go. So that's what Google's web page looks like. You can see that Netcat is not actually the best web browser. But if we scroll up a bit, we can look at some of the, holy moly. I wonder if there's a simpler web page we can look at here. Yeah, we've got tons of JavaScript here. So much JavaScript. So it used to be that this would, when the web was starting, this would probably be enough data to actually crash your computer by using up all of the memory. But we've gotten very blasé about that sort of thing. We don't think about it too much. Tom, can you think of something offhand that would be just plain HTML, like a little less? Yeah.
No. What's that? Example.com.
Is example.com a good
it
example?
might be a more
Let's
compliant
see.
server. We'll see.
Let's see.
Sometimes we can't get away with
Okay.
these like very barely.
Oh, look at that.
working-
Okay.
Ah,
This
nice.
is a better
nice.
example. Thank you so much. This is a better example of what the early web would have looked like. So again, so we've sent in the request, and if we're watching this in Wireshark, we could see this going through, right? All we're sending is the text get slash, which says just give me whatever the main page is on this server, and then everything after that is the response that the server sent back to us. So this is the first section before the new line is the headers. So what HTTP does is, again, like TCP and like all these other protocols, is it sort of takes the data that it's trying to send and wraps it in other data, right? So these headers in this case are the metadata that's sending. So it's telling us, I don't think we need to go line by line through this, but it's giving us information about when we picked up this file, and then it's sending us the file itself. If you look down where the pointy arrows start, this is HTML, which stands for Hypertext Markup Language, and this is the sort of standard specification of how you have a resource that can both contain data and links to other resources.
I can get a better example if we do. So that one was not method not implemented because. Oh no, never mind.
Yep.
Didn't help.
No.
Version
Oh yeah, that's
supported.
right. Yeah, that's
Okay.
right. Technically HTTP, you're supposed to use uppercase for all the methods, but I don't think a lot of servers actually care about
rely
that.
on
Okay, so
Great. Okay, so now we've seen the client side, right? Now this should be a revelation. This should be really exciting because all of a sudden it turns out that we can just, we have a web browser just in our command line. Hopefully you remember the correspondence between Netcat and Python. If we can do this in Netcat, we can do it in Python with 3 more lines of code, right? We make the socket, we connect, and we send, and then we receive. But this is just shorthand for doing it. If we're trying to figure out how HTML works, let's
yeah.
do the other
let's
side.
do it the
of
other way
this.
around. Let's
Yeah.
listen on port. We're not going to use port 80 because we're probably not allowed to. Let's use port 8000. Hopefully that's not being used. So now, so once again, I've got a server, and again, Netcat is just a shorthand for stuff that we can do in Python, right? You've got at least a basic version of a server. So you could do this, it'd just be a little more verbose. And then let's go over here, and let's connect to localhost 8,000. Apparently, Tom has done this before. Okay. So it looks like we're connected. Nothing's happening because our server, we don't have an actual web server sitting there. But if we come back, okay, so up here you can see this is where I told it to listen, and now it's telling me that it's gotten something. And boy, howdy, has it ever. This is what your browser does when you go to a website. It just sends text much like this. Again, a standard HTTP request, telling it what it wants. Telling the server what it's expecting to get, right? So it's saying where the request is going to, it's saying what sort of connection it wants, it's saying what sort of encodings it'll accept for the content, and apparently it's sending a cookie, which we are not going to go into at all.
If you haven't tried this, definitely try this.
Yeah,
right
oh
now.
yeah,
This
like,
is
type,
like
please do
exciting,
type along
visceral.
with this.
After
It's
you do
fun.
this, you're a web developer, right? You're now writing. In fact, you're a server developer too, because you're just right here in the server. It's like I'm just going to have my website be it someone manually typing out responses.
Yeah.
So that's what Rose is about to do, right?
Yeah, that's right.
So now we're going to be the server and
Yes.
write out
Okay,
whatever
whoops,
we want.
not like that, we're not. Okay, what
And
is
again-
it? HTTP.
Missing
Like,
a.
oh,
You're okay. You're
Is
right.
that all
Cool.
right?
No, we got away with
Okay,
it. Yeah.
That's okay.
So we're doing a lot of things here that are barely standards compliant or not quite compliant,
Yeah.
but the browsers will accept. And
Yeah, browsers are not picky because a lot of early web servers, who am I kidding? A lot of web servers are not too picky about what they actually do. Okay, so I've sent back an OK message just saying I've gotten that request, and I'm going to send you some HTML now. Hold on, there we go. And I'm going to send some basic HTML. Don't worry, and again, this is going to be not proper HTML. Whoops, not B1, B.
I think the stuff you got back from Google.
there you go. Yeah.
That's, you can come up here and type it if you want to. I'm not
Yeah.
going to. Okay. All right, so I'm going to send some very terrible, okay. Right. Whoop.
Right.
There we go. Oh, and then I closed the connection. That's right. Okay, and let's see what the browser made of that. Oh, and we've got "hey" written in bold letters. I don't know if you can see that. Right. That's what those B and B's in pointy brackets meant. So yeah, you can actually be your own web server. If you know exactly what you're hoping to find on the internet, you can just type it in yourself at Netcat, and you don't need an internet connection anymore.
Yeah.
Yeah.
Reset the environment here. We've got setting Wireshark aside, which is a tool for monitoring connections and digging up.
Yeah.
You've got Netcat, which is providing the server and the client. You've got Python via the prompt, which is the inactive. And then you've got Python coding. So as you jump between these things, can you clarify which
Oh, sure. Yeah. Yeah. So someone just asked something like, hey, there are 3 different contexts in which we're doing these things that all look the same because my text editor is a terminal. So it's hard to tell when I'm typing code, like for a Python script, stuff we want to repeatedly do, which we've been doing for the projects. Exercises we're typing at the command prompt with the Python prompt, the 3 greater than signs, and Netcat. So 3 totally separate contexts. So thanks you. Yeah, that's a great point. Yeah. So it's just to be very clear here. This is at a command line where we typed Netcat, and and now we could go do the same thing in Python, but we're not going to because it would take more lines of code. Thanks. Yeah, that's okay.
Yeah, that's right. But again, you could in principle do that in Python as well. You're actually at a point now, and I think we'll be getting to that soon, that you could write a very simple web server. Not standards compliant, but you're up there with the best of them. Don't worry about it. I think before we do that, Tom wanted to show you some of the some HTML in the wild.
Okay, cool. Let's do that. We can go back to example.com, confirm like yes, this really is the same thing. We could go to view. Well, we can't because we didn't get a successful request through to them, but we can look at page source here. Cool. And a interesting thing.
I might slow down a bit. So what he's doing here, what the browser does is it gets this chunk of HTML and then it renders for you in a way that's easy for you to look at, like with links that you can click on, for example. And what Tom's doing here is looking at the actual HTML that was sent by the server.
So you could start exploring this stuff now, right? Any website, you're going to be able to go view source, look at that HTML. We've looked a little bit at HTML now, right? But HTTP is the way we're exchanging that information. That's the kind of server we're about to build. HTML is the one thing that was especially designed to transmit, but you use HTTP to transmit a lot of other stuff. For example, on this GitHub web page here, when a neat thing about HTML is this web aspect that Rose was talking about, where it links to these other documents, and sometimes it just pulls in the other documents right there. So when I load this page, it's not just an HTML document. They're embedded in that are other requests. And I'm just going to show a quick kind of little animation of, like, look at these other requests that your browser is making. So if you were going to write a web browser, you would need to ask for the first page, which is going to look like this. So this is the source for that page. There's quite a bit of it, but there was not enough information here for the whole thing. And there's a tab in here. And if I reload this now, we're going to see a bunch of requests being made. So this is a list of all the different requests we had to make. And the very first one on the left is actually getting the page. But then that had a bunch of other listings we were also supposed to go look up. And it kind of cascades down because each one can lead to more requests. And so we're not going to get into this much, but this idea of HTML is powerful because one HTML document can spawn a lot of these HTTP requests. So next up, we're going to build an HTTP server. And at this point, there starts to be enough lines of code that you don't need to do it from scratch anymore. If you look at the next handout, our HTTP handout, bring that up. These are the exercises we just did, plus a little bit. And now we're down to the project, write a web server. I suggest taking this code, and copying it. And then we want to do what an HTTP server typically does, especially on the early web, which is that we're going to receive a request, read the request, and find out what file they were looking for, what resource they were looking for. But early on, that meant file. So someone asks for cat.jpg. We are going to, on our system, open the file called cat.jpg, read the bytes of it, and send them to the browser. Now, I think we may not finish this, but I guess we're going to start this exercise, at least to get something like this running. I'm going to walk you through the code real quick because I'm asking you to copy and paste it. We've seen this stuff before. This is the same as our early server that we wrote. We've seen this while true loop before. It's the idea that with this one program, we might receive one request, deal with it, and then receive another one. We're doing some parsing in here, these requests.splits. This is looking at that first header line and trying to find the middle piece, which was get, and then the second piece, which was a slash before, and could be any file if we're looking at, we saw that before, yeah.
I don't think we
haven't seen that yet. But you can, when we do a request, before we did get slash, that slash could be much more. It could be slash cat.jpg. It could be slash cats.fuzzy1s cat3.png, whatever we want there. And it comes back and says, oh, 404, I couldn't find that one. But that 2 parts, or 3 parts of that first line are the version, we're getting it, and then which resource it is. In the server we're about to build, we're going to find what path they wanted, and then do what early web servers did, which was open a file on our file system that corresponds to that file and send that out. Anyone have worries about the security implications of this? A little bit. So there's traditionally been lots of issues.
You should. Put up your hands.
So we're going to use localhost for this. We're just going to serve it on our own computers. So in this demo, it says localhost here. It should be a string localhost. That's a mistake. But it's important that we don't do this with an empty string, which would mean anywhere, or your IP address, which would mean anyone can talk to your computer and get that.
This was actually a security problem in some early web servers. That you could make a request like, I don't know how well you can see that because it's in gray, but you could request like ... indicating go up a directory and get any file off the user's computer, not just the ones that the server was running in.
Great. So let's go ahead and start this. If you've got this up, I would start by copying and pasting this in. It should be mostly working already. You'll need to change this localhost to be with quotes. And this should already be sending the HTML document hey. So if you can get that working, after that, our goal is to replace the HTML h1 hey line with opening a file and sending back the bytes of that file. What time is it? So I think I think a good goal would be just copying this out and getting the server working as it is, and then you'll be able to tinker with it later for time, probably.
Yeah, I think so.
OK, let's go ahead. Network things will happen. Like, people might have questions. Things might not work. But if we can just get that copy and pasted version running. Hopefully this is also a little bit mind-blowing. It's like, oh, all that an HTTP server is something that sends back those words, like those letters, and then I guess you can read a file back to it if you want to. But turns out there's not that much to web development. I don't know what everyone's making a fuss about. I was not real clear about that. I'm going to actually demo that here while we're going. You're welcome to keep going if you've got it. But so I've got this server. Hopefully it works, but I have to change localhost to the string localhost. That was a typo. I'm going to see if that works. Cool, it's working. Now I'd like to change it so that what it does instead is instead of sending exactly this contents no matter what, I'm going to say, you know what, let's go ahead and open that path. And we can be nice and Python-y about it. With open as f, I'm going to open it in read mode. Also going to open it in binary mode. And then on here, I'm going to say send all, which is a new method we don't know about, which lets you send more than about a megabyte at a time, or maybe however much fits in a single send call, because our file might be bigger than that. This is all in the exercise handout. Great. So hopefully this is code that would open a file on my computer and send back the contents of it. See if that works. Why don't you give me, I don't know, etc/hosts or something. No such file. OK, well, that's good. How about, are we good? There's a slash at the beginning, so it's doing it from my root, which was kind of weird. Maybe it would be better if I took off that slash. Oh, OK, OK, thank you. So I'm going to go ahead and look for that one. Hosts. Cool. OK, well, I got a thing that maybe I shouldn't be sharing with people. So we're running into those security issues. Yeah, just to check, just to find out. So the fix for that would probably be I'm going to do path from 1 on. Again, this is like, once you find yourself doing these little hacks for parsing, you're probably not doing it right. You should use a library that would parse this correctly. But hopefully now I can get the code for this server. If I said, great, that worked. So I typed server.py. This code opened that path, sent it back. And if I asked for an HTML file and I'd written an HTML file, I'd be a web developer again, right? I'd be serving these things. We can just do that real quick, and then we'll move on. real quick, I'm going to make a little HTML file. Uh-oh. I still have to run the server. Cool. So we're doing web programming now, where this is definitely, the title has been validated. This is web programming. But I think for time, we're going to move on. We were... Oh, right. OK, great. We have time to do that. Terrific. Do you want to talk about what happened with web scripting history? OK, so we're going to move on for now, despite I see no green stickies and didn't ask for them. Or I see there's a couple green stickies. Sorry, yeah. Do we do, because we have 20 minutes, is that right?
Yeah, I think so.
Oh, 25 minutes, OK. Great. So we're going to recount a bit more web history for us. So at some point, web servers were things that received HTTP requests and then found that file on their file system. And then someone came up with the idea, well, what if that wasn't a real, this is, again, maybe not real history, but my fake version of history, how I remember things, is someone thought, wouldn't it be great if I could give different people different things? Or wouldn't it be great if I could put the current time on my website? You've seen really early websites that are like, the current time is, and they seem to think that that's a really cool feature. At one point that was, because you were just serving a file. And if you were going to make it give you the current time, I guess you'd write another program to rewrite that file, like, once a second with the current time in it. But there's this idea of, instead of that script rewriting the file, maybe we don't need to do it once a second. Let's just do it anytime it's needed. Let's just run a script every time we get a web request and generate the file ourselves. So this was CGI programming. This is kind of PHP. This is Perl. This is lots of tools that you might use where a request comes in and you run a script real quick to find out what you're going to hand back to the user. And this is an important forerunner, sort of our modern web stacks in Python. It's a little bit different, but it's also really easy to modify the thing we just wrote to do this. So what if, instead of opening a file, like I just did here, we ran a script? In fact, I'm just going to do that real quick, because that might be the easiest way to demonstrate that. So instead of this code here, I think this is all in the exercise too. And we have now moved on to the next exercise thing, but we're starting to get a little off for time. I'm not going to open a file. I'm going to, I guess I'll import subprocess. Actually, you know what I'm going to do? Well, that's fine. I'm going to just run Python, because that's my favorite scripting language. I'll use Python too, though. This is to emphasize, like, this is a different process. I have my server, and when it gets a request, it's going to run a new program and use the output of that for the website. I'll run Python on whatever the file name was. So now I'm letting people run arbitrary files on my computer. It's not great either. So there's security concerns here that add complications. But we'll do Python path. Once again, path maybe from 1 on, so I don't get that first slash. So it'll be a relative path. And instead of popen, I think there's check output. I'm going to say response equals this. Does not send all response. So this is a program that, when it gets a request, will go find that file in the file system and run Python on that, take the output of that program, and send it back as a web page. So this is still a really fundamental web programming tool and exists a lot, but we don't use it as much in Python. So when I run stuff.py, I'm expecting an error from Python, which will say, like, hey, return non-zero status, because that didn't exist. Great. So I'll write one. Stuff.py. So again, these are both 2 files that I'm writing. This one's just going to say, how I print, I don't know, like HTML Maybe we could import time and print time.time. And then we could print closing HTML. So there's a little bit more to, oh, go ahead, thank you, yeah. There's a little more to CGI where you could pass in query parameters, which are the things after a question mark in the path. You could pass in cookies maybe, and then your script got to deal with those. But the general idea was cool. So now we have a script, and we could have just run it once a second to create a file, but we skipped that step, and we are running it each time we get a request. And maybe we could cheat a bit. If you've seen on the web, there is a lot of things where it'll be stuff.pl, and there's a lot of stuff where it'll be stuff.php. And what's probably happening is that the web server is getting that, looking for like a mapping of that file path to something on the server path, running that PHP program, and then taking the output and spitting it back to you as a web page. So that's neat, that's great and all, but that's not. That's, oh, go ahead, yeah.
Maybe we could put people trying to implement this.
Okay, yeah.
WSGI stuff.
That sounds fair, yeah, yeah. All right, so let's look at implementing this. If you've got that working server before, if you've copied that into a file, some people got as far as modifying that to open the file. Now let's try that subprocess thing.
Sorry, before we do that, can we just get a show of stickers? How many people have at least the copied server running on their computer? Yes. Okay, looks like
that's
looks like
that's
most people.
doable.
Okay.
Great. Okay, so let's make this change. Again, it's going to be real important that you're binding on localhost, because someone else, even though I wasn't able to figure out how to send messages between computers here, someone else probably could figure it out, and then they could be running arbitrary code, well, arbitrary files, which could be like arbitrary code, on your computer. This is the interesting part, right? This is the part we're changing. You'll have to import subprocess. Check output is the easiest call to use. Check output takes a list of as many things as you want. In this case, it's going to be Python every single time. And then on this side, it'll be the path. Then the check output is saying, run a program called this, and then pass this thing as an argument to it. This is also in the exercise document, but this is going to be easier. And hopefully this is also this empowering moment. It's like, I could run a server that, I guess I'm telling you not to run this in the open web, but you could run an HTTP server that runs arbitrary code. Like you're a web developer now. Like if you're running this code, you had to write this program over here. Whatever you put in that is what they'll see. That's a lot like modern web development, where we're starting to write code that generates the HTML. There's still one step, as you might guess, from the exercise. One hand. Going okay? Someone pointed out I might have been running this with Python 2 and not caught an error with it. Nope, I think I ran it with Python 3. Maybe you're using Python 2? Oh, okay, yeah, yeah. It's an error in your subprocess. Like a classic thing. Sure, yeah. Yeah, sorry, it didn't all fit. How's time? Okay, so wrap up next.
Yeah, I think so.
So a couple people have pointed out something I was quite unclear on. When we're running this, it's important that we write a second file that, in this case, because I'm running Python on it, better be a Python file. And this is the one that's going to be called in a subprocess. So I'm calling this template. I think we wrote one called stuff already, stuff.py. And that needs to be a valid Python file. And it might help to check that ahead of time to say Python stuff.py, is that working? OK, great, it is. Then, so debugging now becomes harder because we're running a Python program inside of this Python program. And that might seem kind of silly, like why start a new whole Python process? And you're right, it is, and that's the next thing we'll talk about.
Shouldn't it be Python 3 on yours because you're using Python 3?
Yes, exactly. That's exactly what I'm doing. I'm using Python 3 and then calling a Python 2 script. So that's kind of silly, but it's to emphasize that it's more likely that this is PHP. Right? More common would be or Perl or something, right? A totally different program, or Bash. So a totally different program here that I'm going to use to evaluate my template, which was stuff. And we're just writing the server. I think we just like totally skip it. That sound good?
Yeah.
And go right straight to concluding.
I
It'd be nice to
yeah,
start.
I think we basically just mentioned this game. This is how modern
Cool.
frameworks work. But
Sounds good.
exercise it with local
Yeah,
code.
oh, definitely not. Yeah. I'm not even going to show the code, I think. Could say any of these things. We actually have to go on, sorry, but let's chat afterwards. Yeah. So we're about to wrap up. I'm going to briefly talk about where we might have gone next, which is this thing called WSGI, which is this idea that instead of going to a sub-process, let's just use the same process. Let's just run a Python function in there to generate the response that we want. But first, I'll let things die down. And all of that is in the exercise handout, or not handout, but the exercise that you've got there. So if you want to go through that on your own, you can kind of see, oh, this is what it would be like to build this WSGI server. The reason that last step is important of this thing called WSGI, which is just the idea that, like, why don't we just have a constant signature you call a function with? Like, is that you get to separate your application code from your server code. So far we've been writing the server and then also writing the thing we want it to do. But we should not have to write servers to do web programming. It's hard work. You have to write a little HTML or HTTP parser to parse those headers. You have to do a lot of things, and it's nice to leave that to someone else and just write the application part, or vice versa, just write the server part. So that's the big idea of this WSGI thing that we're not doing the exercise for. And generally, as some concluding remarks, I hope that the frustrations and errors of this, I hope you had some errors. I hope you were stuck at some points. Because the most translational part, the part of this workshop that is most useful in kind of real network programming or like web development are the errors. Because those are the thing, the goal, someone writes a library that's supposed to take care of all this stuff for you. And so you never see it unless you get one of these errors in their code, and you have to figure out, oh, it's because I didn't bind to this socket, or, oh, now I'm not intimidated by this kind of error because I've seen it before. I think the programs we wrote were somewhat simple because we're dealing with setup and network things that are more complicated. And the big thing to take from this tutorial is that it's easy to get things working. It's hard to get things right. And there are a lot of errors you can get that might bubble up. So you might be working in a library that uses a library that uses a library that uses a library, but at the bottom there's sockets. And if something's wrong with a network, there might be an error there. It might not get caught. You'll see that, and you'll be able to say, oh, I guess maybe the network's not connected. So you have to do any of this kind of network programming, you start to develop a sense of what a socket server means, even if you don't normally do socket programming. In Brandon Rhodes's book, so the PyCon chair this year has written a book on Python networking called Foundations of Network Programming in Python, I think. And near the beginning, he talks about, OK, a realistic example of how you might do networking is this layers idea again, but talking about it in Python land. So maybe you want to geocode, use this Google API that geocodes an IP address. And so the first thing you do is you pip install the library that does that. There's a client library that does all the networking for you. Maybe the client library doesn't exist, so you go down one level and you use requests, which is the standard thing to use in Python for doing HTTP requests. Maybe for some reason, the thing you're doing isn't quite HTTP, so it doesn't work like that. Well, maybe use like another library, maybe use Twisted, maybe there's a protocol in the Python standard library that implements this already, so you don't have to be writing the actual bytes like we've been doing today. And then finally, maybe you actually have to go to the sockets. But most of the time, you don't have to go to the sockets. The sockets are the assembly language of network programming. And in the same way that most of us don't have to go down to the assembly if we don't want to, it's kind of a fun exploration. It's not something we have to do. Most of the time, we don't have to go down to sockets there. I wanted to share, some of this is on handouts. So we have a couple handouts for you. One of them is more detail about the implementation of networking by the incomparable Julia Evans, who you may already have this, but we're going to give you a paper copy of Networking ACK, because it's great. There's also a handout that is called What Next? Or
Where to go from here.
Yeah, where to go from here. That's a more wordy way to say what next. And that has a list of other tutorials that are going on right now or tomorrow. And they're sold out, so you can't attend them, but there'll be videos posted. And those might be good things to look into next if you're kind of interested in this sort of network programming. There are talks. There are 2 talks on Friday that might go well with the content we had here. I don't have them here, but they're on this handout. One of them is how micro-WSGI works and what it's doing in very literal terms. And I think they'll probably be talking about sockets. They'll say, here's this thing called UWSGI or micro-WSGI. I don't know what it's usually called. And we're going to explain it at the most fundamental level, which hopefully will be sockets. Some of the terminology that we used hopefully will be useful if you're doing web framework programming. What else? Python has a couple things you should be aware of. If you ever wanted to do a local file server like we just tried to do, you don't need to write it yourself. This exists in Python. There's a module called HTTP here. Well, we're in Python 3, called HTTP. And in particular, if you're at the command line, you can say python 3-m server.http. And this runs an HTTP server in port. Oh. Oh, it always does that, huh? That's a bad demo. Okay, there we go. This runs an HTTP server in your current directory. There's another version of this that does it for a CGI server. Python comes with a lot of this stuff. And if you're trying to do a network thing, there's probably a Python library for every level of that. So you can go as high level as you can, and then maybe you need something special, so you have to drop down one layer. You want to use requests, but you need to do them concurrently in a way that the request library doesn't quite support. Well, there is the URL lib library, or HTTP lib in Python. And so if you know about some of the rungs of this ladder, you don't need to go all the way down to sockets. Anything else?
No, I think that's it.
Great. Hey, thanks so much for coming. I'd love to talk about this or anything else over the course of the conference. Same?
Yeah.
Yeah? Okay. Great. Thanks a lot.